On Tuesday, we learned about special right triangles, the 30, 60, 90 and the 45, 45, 90. All right, the 30, 60, 90 can be a little bit difficult to remember what lengths go to what sides. So here's the trick. You got to at least remember the lengths of the three sides, which are 1, 2, and square root of 3. 1, 2, and square root of 3 are going to be these three sides. It's just which one goes where. All right, well, what do you think if you had to list these in order from smallest to largest? Obviously, 1 would come before 2, but where does square root of 3 go? Is it the smallest, is it the largest, or is it in the middle? Well, square root of 3 is a little bit less than square root of 4. Square root of 4 is 2, so square root of 3 is a little bit less than 2. Square root of 1 is 1. Square root of 3 is bigger than the square root of 1. So basically what I'm saying is square root of 3 is in between these two numbers. Square root of 3 is like 1.7 something. So it's in between 1 and 2. The reason I'm telling you that is because whatever side is across from the smallest angle is the smallest side. Whatever side is across from the 90-degree angle, aka the hypotenuse, is the longest side. So the longest side in a right triangle is always the hypotenuse. And the shortest side is across from the shortest angle. So 1 is going to be across from 30. 2 is going to be your hypotenuse. And square root of 3 is across from 60. So that's how you remember this triangle. As long as you can remember 1, 2, and square root of 3, you should be able to figure out where they go with that little trick of the hypotenuse is always the longest side and the shortest side is across from the shortest angle or smallest angle. All right, 45, 45, 90, you've got 1, 1, and the square root of 2. Square root of 2 is about 1.41, which is bigger than 1. So square root of 2 is the biggest side. That means it's the hypotenuse. And then your 1s are your two legs. All right, so that's how you set up those two triangles. Now today, instead of using degrees, we're going to use radians. So 90 degrees as a radian measure. 90 degrees is 1/4 of the way around the circle. All right, halfway around the circle is 180 degrees or pi, and we're halfway to pi or halfway to 180. So we're half pi. So remember the little formula, degrees times pi over 180, 90 times 180 cancels out to a 1 and a 2. That's 1 pi over 2 or pi over 2. So 90 degrees is pi over 2. How about 30 degrees and 60 degrees? 30 is 1/6 of 180, so this is 1/6 pi. 60 is 1/3 of 80, so that's 1/3 pi. And if you add these three numbers up, it's still triangle sum theorem. You should still get 180 degrees. 180 degrees is pi radians. So if you add these up, they should equal pi. And do they? 1/6 plus 1/3 plus 1/2, pi over 2. Does that all add up to pi? Well, let's make common denominators of 6. So this would be pi over 6 plus 2 pi over 6 plus 3 pi over 6. And 1 pi plus 2 pi plus 3 pi is 1 plus 2 plus 3 is 6. So you get 6 pi over 6. Your 6's cancel out, and you're left with pi. So that's right. That's how you can check to make sure you've got your correct radians. They have to all add up to pi, because pi is 180. All right, so we've converted our 30, 60, 90 triangle into radians. And when it comes to the circle, the unit circle, you're going to have to get used to seeing them in radians. That's just how it's done. It's annoying, but that's how it is. So you're going to have to get used to it. All right, let's convert this one down here. 45 degrees, that's a little bit trickier to do in your head, but 45 goes into 180 an even amount of times, 4 times. So 45 is 1/4 of 180. So that means it's 1/4 of pi, pi over 4. Pi over 4 plus pi over 4 plus pi over 2 equals 1 whole pi. All right, if you can't do that in your head, you do 45 times pi over 180, and 45 over 180 reduces to 1/4, so it's 1/4 pi, or just pi over 4. All right, these are your main, just like on Tuesday, I said these are your main degree measures, 30, 60, and 45, and multiples of those on the unit circle. You're going to have to be able to solve for sine, cosine, tangent using fractions, not decimals. Same thing with today. You're going to have to solve for sine, cosine, tangent using fractions, not decimals, but they're going to be in radians, not degrees. So here's an example of what a problem might look like. 240-degree angle. That is, you always start with an angle on your circle from right here. So 240 degrees is 180 to here plus another 60. So it's this big angle. It's opened up more than a straight line. So if we want to know what sine of 240 is, what are we going to simplify this triangle down to, 30 or 60 degrees? It's a good question because 30 and 60 both go into 240. So are we going to take the sine of 30 degrees, which sine of 30 degrees is opposite over hypotenuse, is 1/2. Or are we going to take the sine of 60 degrees, which is opposite over hypotenuse, which is square root of 3 over 2? Two different answers. So how do we know which one to use here, 30 or 60, because they're both multiples of 240? Well, think of this quadrant that it's in. Every quadrant is 90 degrees. All right, so 240, if this is 180, then this right here is 60, and this one's 30. All right, this angle right here is a 60-degree angle. This angle right here is a 30-degree angle. So is it the triangle like this, and we're using the 30-degree angle, or is the triangle this one over here, and we're using the 60-degree angle? It's this one. Your leg on your triangle that you're going to draw always goes to the x-axis. You never draw it to the y-axis. All right, just like if you had a 60-degree angle here, say that was 60, you wouldn't say, okay, there's my 60-degree angle. No, you always start from here and go around. This is your 60-degree angle. Your line goes down to the x-axis and never goes across to the y-axis. So 240 is the same as 60, not 30. So sine of 240 is square root of 3 over 2. But remember, square root of 3 is this length over here, and it's going down. Your y values for these points down here are left and then down. So your y coordinate is negative. So this is negative square root of 3, and the hypotenuse is always positive. This was the one mistake that I saw the most common on Tuesday, was that people wanted to make the hypotenuse a negative number. It's not negative, it's always positive. So it's negative square root 3 over 2 is the answer to the sine of 240. Now, today's problems, you're not even going to have the 240 in there. You're just going to have radians. So what is 240 in radians? Well, you can do the little formula, 240 times pi over 180, and 240 over 180 reduces to 4/3 because 60 goes into both of those evenly, 4 times and 3 times. So it's 4/3 pi. All right, it's going to be more than pi because 180 is pi, and 60 degrees is 1/3 of this bottom 180. So it's 1/3 past pi, 4/3. 1 pi plus 1/3 pi is 4/3 pi. That's how you can think about it in your head, but you don't even have to think about it in your head. If you just use this formula, it'll give you 4/3 pi. So that's going to be what the problem looks like in today's homework. Is say find sine, cosine, tangent of 4/3 pi. So you might think, I don't even know where to start here. So you go back to this and you look at your denominators. All of the problems in today's work are going to have a denominator of either 2, 4, 3, or 6. All right, so when it comes to radians, you got to look at the denominator. The denominator is the key. The denominator will tell you which angle you should be starting from for sine. If your denominator is 6, you're starting from 30 degrees. It's 1/2 or some form of negative, positive 1/2. If your denominator is a 3, you're looking at it from the 60-degree standpoint. If your denominator is a 4, you're looking at it from the 45-degree angle standpoint. And if your denominator is a 2, you're looking at it from the 90 degrees. It's either straight up and down and there's no adjacent side, or it's straight across and there's no opposite side. All right, so it's tricky. It's hard enough with degrees because this is a new subject, and I'm flying through this week, people. I understand that. When you get to high school, all this stuff that I taught you this week, every lesson will be just about a week in itself. Maybe not quite, but everything that I'm teaching you this week will take you probably 3 to 4 weeks to learn once you get into high school. So if you're a little confused, it's only natural. But when you see it again in high school, hopefully this will help and it'll make a lot more sense to you.